Hello everyone. So today we're going to continue 1.6. 1.6 talking about other equations. So here other equations. So left for 1.6 one example. So we're starting to talk about 1.6. I give example for a polynomial of fifth degree. Then I move to a fractional expression. We solve one example for fractional expression to solve the equation. Then the last thing here we left the radical. So for example, if I have something like this. So example, the question is solve x equal 1 minus the square root of 7 minus x. 7 minus x. Any idea for doing something like this? Any idea for how we can solve something like this?
Subtract 1 from both sides.
Okay, this is correct. So when you see something like that, I prefer to make one side the square root and the other side everything left from the equation. I mean, like I prefer to make this side just the square root and the other side everything left from the equation. Like here we have to subtract -1 from both sides. So by subtracting 1 from both sides, -1, -1, 1 and -1, they will cancel out. This would be cancel out here. And here I get x minus 1, x minus 1 equal the square root, the minus of the square root of 7 minus x. Now the second step is to square both of the side. Why? Because when I square both of the side, I will cancel the square root. I will cancel the radical. So the best thing here now, square both of the side. So here, take the square root of this one, and then take the square root of this one. So what I get in this side? What can I get this side? Any help for this?
Wouldn't it be -7 plus x?
The square
Exactly.
of the 7 minus x.
Yes, this is correct. X squared on this side, first of all, x squared minus 2 times the first step. I mean, like here, 2 times the first term is x times the second term is 1 plus the second term square. Here is -1 square. And from this side, the -1 here square is 1, and the radical will be cancelled. So I get here 7 minus x. Now I will move and simplify everything to the one side. I will move the 7 to this side, and I move the -x to this side. And in the same time, I will simplify everything here. So now I get x squared minus 2x plus 1. So to move the 7 to the other side, to move this one here to this side, I have to subtract the 7. And to move the x to this side again, also, I have to add x. So subtract 7 from both sides, I will get minus 7. Here, minus 7 from both sides, minus 7. Then also I will add 7x. So add x for both sides plus x. I will get minus 7 plus x equal, I will get minus 7 plus x. This is minus 7 plus x equal 0. Now I will simplify it more. So I get here x squared minus 2x plus x. They will give me minus x. Plus 1 minus 7. They will give me minus 6 equals 0. So now I get like, after I simplify everything and I move everything, I get like I get like equation, and we saw something like this. What kind of equation is this? X squared minus x minus 6. What kind of this equation? Is a quadratic, exactly. Zainab said this is an quadratic equation. This is correct. Why? Because the variable x has raised to the power 2. So the variable x here raised to the power 2, or I can say the highest power in this equation is 2. This is a quadratic equation. So I change the other kind of equation as a quadratic equation. Now I can solve it by the step I learned in the 1.4. So here I get another question from Ryan. Where did the x times 1 plus minus 1 square come from? Oh, okay. So here x minus 1, this one here, is exactly like x minus 1 squared. This is equal x minus 1 times x minus 1. Okay? X minus 1 squared equal x minus 1 times x minus 1. Now distribute the x with the parentheses and the minus 1 with all parentheses. So I can get now x times x minus 1 minus 1 times x minus 1. Now distribute the x inside, so I can get x squared minus x. Here, distribute the x inside the parentheses, and the same thing is the minus 1 inside the parentheses. So I will get x squared minus x minus x minus 1 times minus 1, they give me positive 1. So actually I get x squared minus x is minus 2x plus 1. It makes sense, Ryan? So that's why here x squared minus 2x times 1 plus minus 1 squared. Or if we want to use like a formula, the formula said, I don't know if you see the formula before, the first term, the formula said, by using the formula here, the first term square minus, the minus is the same as the sign here in the middle, minus 2 times the first term is x, times the second term, the 1, plus, you have to write plus here, the second term square. The second term is minus 1 square. This is a formula. I don't know if you say it in the high school. So the first term here, x squared, is x to the power 2 is x squared minus 2 times x times 1, they give me 2x, plus the minus 1 squared, they give me 1. So both of them, they give the same answer. x squared minus 2x plus 1, x squared minus 2x plus 1. So you can solve it in the way you like. Now let's back to the question, to the example, sorry. So here, x squared minus x minus 6. So how can I factor, or how can I solve a quadratic equation like this? So last time I said we have 3 ways to solve a quadratic equation. The first one is by factoring. The second way is by using the quadratic formula. Third way is by using completing the square. Again, last time I said we have 3 ways to solve any quadratic equation. The first one is by using the factoring. Second way is by using the completing the square. And third one is by using the quadratic formula. But here we're going to use the factoring. What is the factor of this quadratic formula? I'm looking for 2 numbers. The multiplication is minus 6 and the sum is minus 1. Bilal said is x minus 3 times x plus 2. This is correct because minus 3 times 2, they give me minus 6, and the sum of minus 3 plus 2, they give minus 1, the second term, the coefficient of the second term. So here I can factor this one by x minus 3 times x plus 2 equals 0. Now I will use the zero product property. The zero product property, I will remind you from last time, said if I have a times b equals 0, if and only if a equals 0 or b equals 0. So by using the zero product property, this one, if I have ab equals 0, a times b equals 0, this means a equals 0 or b equals 0. So the same thing here. If this is my a and this is my b, so this is my a here, and also this is my b. So a times b equals 0, so a equals 0. So my a here, x minus 3 equals 0, or x plus 2 equals 0. So when x minus 3 equals 0, I add 3 for both sides. So they will cancel out, plus 3. So now I will get x equal 3. Here I subtract the 2 from both sides. I will get x equal minus 2. So the answer is x equal 3 or x equal minus 2. But I have to check before that, after that, like last time, I have to check the answer, right? Laila said a equal 3, b equal minus 2. Yes. No, a equal x minus 3 and b equal x plus 2. This is b. All this is b. All this is a, my a. All the parentheses is my a. All the parentheses is my b. So all a x minus 3 equals 0. The parentheses, the first parentheses equals 0, or the second parentheses equals 0. Then I solve the linear equation. This is a linear equation, basic equation from section P8. P8 is a linear equation, the first section for solving equation. Adding 3 for both sides, I will get x equal 3. And the other one is x plus 2 equals 0. Now I subtract the 2 from both sides. I will get x equal minus 2. Now I get 2 answers. The first answer is x equal 3. The second answer is x equal minus 2. But I have to check right now. Like last time, I checked the answer and the fractional expression. I was checking the answer. I plug the answer. I plug the x equal, like I plug the solution inside the formula to make sure it's work fine. So now let me plug the x equal 3 inside this example, inside this formula expression. So here I get 3 equal 1 minus 7 minus 3, 7 minus 3, they give me 4. So for the first answer, I will check. Now check the answer. Here. Check the answer. So for x equal 3 and for x equal minus 2. So for x equal 3, just plug the 3 inside the formula, inside the expression. So for x equal 3, I would plug the 3 inside this one, x equal 1 minus. So I have to plug it inside the formula 3 equal 1 minus the square root of 7 minus 3. Now I have to get this side equal the same like this side. So here I will go down 3 equal 1 minus, this goes down, the square root of 7 minus 3, they give me square root of 4. Now again goes down 3 equal 1 minus 3. So 1 minus 3, they give me what? 3 equal minus 2. And this is not correct. The 3 is not equal minus 2. Now here I get 3. 1 minus 3 is minus 2. Is the 3 equal minus 2? Is this answer, is the 3 equal minus 2?
No.
No, this is not correct. So the 3 not equal minus 2.
The square
So
root of 4 is it would be
x,
minus 2, not minus 3.
what is that?
It's 1 minus 2, not 1 minus 3.
1 minus, oh, so, yes, this is correct. 1 minus 2 here. Yeah. Because the square root of 4 is 2. 1 minus 2, the same thing is minus 1 minus 2 is minus 1. And the same thing, 3 not equal minus 1. So x equal 3 is not a solution. So I'm going to do the second one for x. Now for x equal minus 2 to check. Here for x equal minus 2. So you plug it inside the equation, I get 3, x is minus 2 equal 1 minus square root of 7 minus 2. This goes down again, so minus 2 equal 1 minus square root of 7 minus 2 is 9, square root of 9. Goes down here. Here I get minus 2 equal 1 minus 3. And minus 2 equal 1 minus 3 is minus 2. So minus 2 equal minus 2. This is correct. So x equal minus 2 is a solution. Is a solution. So the only solution is x equal to, this is not correct here. So this is not a solution. And this is correct. So x equal minus 2 is a solution. Any question for this example? Okay, so if no question, I'm going to the next section. So the new section is 1.1. The new section is 1.1, the coordinate plane. One point one. The coordinate plane.
Sir, I just want to make sure. So when there's an equal sign and there's a slash between it, it means that it's not, right? Not equal to.
Where? What is your
Yeah.
question?
Oh, I was just asking, like, in some of the, when I was looking back at the notes, sometimes there's like equals to and slash. So I was just
This
making
one?
sure. No, I was just looking at the notes. I just wanted to like quickly just make sure.
Like something like this?
Oh,
Here?
yeah, something like that.
Yeah, this means not equal.
Okay, thank you.
You see something like this? This is not equal. Okay. So here equal, but this is not equal. So like this. The coordinate plane. So I'm going to give what is the meaning of coordinate plane. So if I have a points in a plane can be identified with order pairs of numbers to form the coordinate plane. I mean for that, so let me give like the definition, right? The definition here. So I can say here it's a point in a plane can be identified with order pairs of numbers to form the coordinate plane or the Cartesian plane. So this is the definition was the meaning of coordinate plane. Points in the plane can be identified with order pairs of numbers. This order pairs of numbers can form the coordinate plane or the Cartesian plane. So first of all, we have to know if I have a perpendicular real line, this perpendicular real lines that intersect at 0 on each line. So like something like this, if I have two lines, these two lines are intersect, these two lines are both of them intersect here. This point is called 0 or the origin. So here I can say perpendicular line real lines that intersect at 0 on each line. So at 0 on each line. So I mean like I have two lines. These two lines are intersect at this point. This point is called the origin. These two lines, they have a name. This is the x-axis. It's called the x-axis. and this line called the y-axis. This point here, the intersect, is called O, or mean the origin. This point is the origin, called by O, or the origin. Now, the two line, this two line, if you see this two line, the first line and second line, divide the plane into 4 quadrants. So we have the first quadrant, second quadrant, third quadrant, and fourth quadrant. So I can denote it by something like this here. The first quadrant is called I. This is I. This is here double I. This is here 3. 1, 2, 3. And this is the fourth here, the fourth quadrant here, IV. And you have to know, here we have this I here, something look like this. This is like this, and this here, and also this is like this. This is the first quadrant, second quadrant, third quadrant, and the fourth one. And we should know any point in the origin in the Cartesian plane or the coordinate plane can be defined as order pair A and B. So I can set here any point in the coordinate plane can be defined by order pair. So, like A and B, A comma B. So A called the Cartesian, the X coordinate, and B called the Y coordinate. So this A here called the X coordinate and the B called the Y coordinate. So this is like a general idea about the coordinate plane. We have to know we have two lines. These two lines are perpendicular real lines. They are intersect at 0 or the origin. This line called the y-axis, this is the x-axis. The two lines that divide the plane into 4 quadrants. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. And this is the definition, the general definition of the coordinate plane. Now the important things, we have to find the distance and the midpoint for between any 2 points inside or on Cartesian plane or in coordinate plane. So here I can define a new thing. So I'm going to move to the next slide. So here I'm going to define the distance and midpoint formula. So I have 2 important formulas in this section, is the distance formula and the midpoint formula. So the distance formula, here is the distance formula. Suppose I have the Cartesian plane look like this here. Here's my Cartesian plane. And I have 2 points like this. I have 2 points. The first point here, this is my first point, is A, x1, comma, y1. And the second point is here. It's called B. The B has order pair is x2, comma, y2. And the question is, find the distance between these 2 points. The distance between this and this. This is my question. Distance between these 2 points. So to find the distance, we have a formula. The formula said, the formula says, if I have the distance d, denoted by d, between the point A, comma B, is equal the radical between the first point, between x2 minus x1, x2 minus x1 square, plus y2, this y, y2 minus y1 square. This is the distance between the 2 points. The distance between this point and this point is the difference between the x coordinate of the order pair for each point plus square, plus the difference between the y coordinate between each point square. Here I get tau said y2 minus y1 over x2 minus x1. This is not the distance. This is the slope of the line. But this is here the formula. This one talk about the distance. The distance. This is the formula for the distance. The square root of the difference between x2 minus x1 square plus the difference between the y's square. So tau, this is the formula of the distance. Now, so here's I can set the distance between A, comma B. Distance between A, comma B. Now the formula for the midpoint. The midpoint formula. So here the midpoint formula. Midpoint formula is called by M, first of all, is the point between A and B. So suppose would be like around here. So this is the midpoint formula. The midpoint formula looking for the point in the middle of this line. So I call it here by M, comma, X and Y. So this is my midpoint, the green point. So the midpoint formula, M of X, comma, Y equal, we have to sum X plus X2 over 2. So open parentheses, X1 plus X2 over 2 and Y1 plus Y2 over 2. This is the formula of the midpoint. Yeah, this is good, Anta. x1 plus x2 over 2, comma, y1 plus y2 over 2. This is correct. So this is the formula of the midpoint. Okay, so this is the formula for the midpoint. So now I will, it's easy to do example by using this formulas. So the first, here's the first example. The example said, so if I have example here, so the example, so the question is, we have 3 parts in this example. The first one, plot the point A. First point is A is -4, comma, -3. This is the first point, A. And the second point, and B, is 3 and 2, 3, comma 2. This is the first part of this question. Second part, find the distance between A and B. The last part, find the midpoint M between X, comma, Y. The midpoint M, X, comma, Y. Okay. Who will do this, the first one? Let me do this in the next slide here. Who will do the first one? So I'm going to plot, to draw the x-axis and the y-axis. Yes, I will go back here. Okay, so how we can do the first one? Plot the point -4, -3. So to plot this point, the -4 and -3, so this is my x coordinate and this is my y coordinate. This is called the x coordinate. This is my x value and this is my y value. So to plot this point, first of all, I have to go to the x-axis. This is my x-axis. And this is my y-axis. So go to the x-axis and put this point there, over there. So I have -4. So the -4 will be like around here. This is the 0, -1, -2, -3, and the -4 is here. So this is my -4. So this is my -4. -4 and -3. So for the -3, again, the same things. I have to go to the y-axis. So here's the -1, the -2, And again, the same thing here, minus 3. So the point will be like around here because the minus 4, like around something like this. So the point will be like 3 and minus, and the minus 3 and minus 4. Like the point will be like around here, this point. So we plot the first point, minus 4 and minus 3. The second thing, for the B, for the second point, 3 and 2, the same thing exactly, nothing different. We have to go to the 3 on the x-axis. So here is the 3. 1, 2, 3. This is 3 and 2. 1, 2. So the point will be like around this. Here. Like around here. This is my second point. So again, here is 2. So 3 in the x and 2 in the y. 3 and 2 will be here. This is the point B, and this is the point A. Minus 4, comma 3, and B is 3, comma 2. Now the second question, find the distance between A and B. So the question is to find the distance between both of these 2 points. The distance between this one and this one. Who will do the second one? Yes, go ahead. Go
Okay,
ahead, Anta.
so what I did was I just substitute the x and y into the formula. So I did d equals
Okay.
square root of
So second one.
parentheses
So what is the formula? D of AB
d equals
equal
square root
square root of what?
x x2 minus x1 square
square. Okay.
plus y2
Okay.
minus y1 square.
Correct. Now, what is x1 and what is x2?
X1 is x1 is 3 and x2
X1
is minus 4.
Okay, this is x1 and this is y1 and this is x2. Okay, and this is y2. So x2 is, you said, is minus 4, right?
Yes.
Okay, minus 4 minus what? Minus 3. Okay, go ahead. What is
Plus,
y2?
minus 3 minus 2.
Y2 is this one, right?
3, yes.
Minus what?
Minus 2.
2. Okay, square. Now, simplify this one. Minus 4 minus 3 is minus 7 square. So here now I will get minus 7 square plus 3 minus 2, they give me 1 square. Now, minus 7 square is, what is the minus 7 square?
49.
49 positive. So this is 49. And what is the 1 square?
I think I made a mistake because
Why?
it's supposed to be a
Minus 3
x
here.
minus 3. Yes.
Okay, the point here is not 3, it's minus 3.
Yes.
I write it down wrong here. So the point here should be minus 3. Now you plug here minus 3. Here minus 3. So minus 3 minus 2 is
Minus 5.
minus 5. Yes, this is correct here. So now get minus 5 square. Minus 3 minus 2, I get square minus 5. What is the square of minus 5?
25.
25 square, 25. Now take the square root of 49 plus 25,
Is 74.
74. This is correct. And this is my final answer, is 74. Any question for this? So the answer is the distance between A and B is the square root of 74. Natasha, this is correct. Okay, the square root of 74 is the distance between this point A and this point. Now the second one is find the midpoint. So actually the midpoint will be as a point in the middle. So it will be like around here. The midpoint will be like around something here. This is my M. This my M. The midpoint of X comma Y. So what is the formula for the midpoint? Midpoint of X comma Y. Who will do the midpoint?
I can do it.
Yeah, go ahead.
Midpoint is x1 plus x2 over 2.
Hold on. X1 plus X2 over what?
Over 2.
Okay.
Comma y1 plus y2 over 2.
Y1 plus Y2 over 2. Okay. Then what I have to plug here?
So it would be -4 plus 3.
-4 plus 3. This is correct. -4 plus 3 over what?
2.
2. And the second one?
-3 plus 2 over 2.
Yes, exactly. -3 plus 2 over 2. And what I get? The midpoint, M, after you simplify everything.
You get -1/2.
-4 plus -1/2. And here?
Negative
Again, negative
5 over 2.
No, -3 plus 2
Oh, sorry.
is -1. Yeah. So
Negative
negative
1.
again 1/2. Yes, makes sense. Correct. Thank you, Amr. 1/2 again. So the midpoint is -1/2, -1/2. Again, you use the formula x1. Okay, let me do it fast because it goes down. I think some students, they cannot see what I write down here. Okay, so first of all, you have to, like Amar said, you have to write the formula. The formula said x1 plus x2 over 2, comma y1 plus y2 over 2. Then you plug this form inside this formula, m of x comma y equal x1 is -4 plus 3, -4 plus 3 over 2, comma -3 plus 2, again -3 plus 2 over 2. And from this order pair, I get m of x comma y equal minus 1/2, comma minus 1/2. This is the midpoint, minus 1/2, minus 1/2. So actually the minus 1/2 would be like around here, this point here, and also around here for the x. So again, the midpoint would be like in the x coordinate is minus 1/2 here, and the y coordinate is minus 1/2. So midpoint, again, if I ask in the exam in which quadrant the midpoint, you should to know it's in the third quadrant, because this is the first one, second quadrant, the third quadrant. Any question for this? It makes sense, clear how we can find the distance and the midpoint. Okay, so now this is the only thing we have to know in this section. Now let's move to the a new section is 1.2 graphs. So in this section you have to know only the distance formula and the midpoint formula. In the new section you have to know how to graph. So now 1.2 graphs, or graph of an equation. Graph of an equation. 1.2 graph of an equation. So first of all, we have to know what is the mean of a graph. The graph is mean we have to plotting many points as we can. Then we connect this point by smooth curve. This is what I mean of a graph. So I will write down the definition of a graph, mean like plotting many points as we can, then connect this point by smooth curve. So we just plotting many points and we collect this point by smooth curve. Now I will give example to show how we can graph an equation. So the example one, sketch of equation 2 times x minus y equal 3. So the question is, sketch this equation 2x minus y equal 3. How we can graph something like this? Any idea?
You can
So-
make it into y equals mx plus b form.
Exactly. So the first step, we have to make the equation for y, like y equals something. We cannot like starting plotting this equation or graph this equation right away. We have to make the equation. We have to solve this equation for y. I mean, solve it for y, make the equation y equal. Natasha said y equal to x minus 3. This is correct. So I'm going to do it step by step. First of all, we have to write here first make the equation as y equal something. So to make this equation y equal, we have 2x minus y equal yx minus y equal 3. So we have to solve it for y. That's mean we have to move this y to this side. Then we have to move this 3. You see the 3? The number 3, this one, move to this side. So the 3 should move to the other side and the y move to the other side. So to move the y to this side, we have to add y for both sides, plus y plus y. So when I add y to the both sides, I get 2x equal 3 plus y. Then to move the 3 to this side, I have to subtract 3. So minus 3 from both sides. When I subtract the 3 from both sides, this will be cancelled out. Now after this, I will get y equal 3. I will get 2x minus 3 equal y. 2x plus 3 equal y. Now, or I can write it in a different way. Y equal 2x minus 3. So this is the first step. I have to make the equation, or I have to solve the equation for x. I have to make the equation y equal, solve it for y. I have to make it y equal the 2x minus 3. So now next step is to make a table, small table. So we should to make a table. So I'm moving to the next slide. So again, my equation, y equal 2x minus 3. I should to make small, I should to make a table. So the table has x value, random x value, and same times I have the answer of this x value after I plug the x value inside the equation y equal 2x. So x now have to take 5 random points, 1, 2, 3, put here, I'll move this point here. And the same thing for the other one. There you go, here. Now also I will plot the graph, the x-axis and the y-axis over here. So let's take some random points. Which point would you like to use for the x coordinate? So suppose this is my x, this is my y, the y equal 2x minus 3, and this is my order pair x comma y. Now, which point would you like? I would like to use the 0 and negative numbers and positive numbers. So if I start from 0, I would like to use the -1 here, and also -3, and the same things here. I mean -1, yeah, -1 and -2, and the same thing here. How would you like to use the 1 and the 2? Also, I would like to use the 3. So what is the value when I plug these numbers inside this, the y? What's the value of -2 when I plug it inside the y? Go ahead, Ant.
So if you want to know what is y equals to, you have to substitute the x
Exactly.
into the equation.
So what I get, y equal 2
2
times
times -2 minus 3. So you're gonna get -7.
-7. Why? Because 2 times -2, they give me -4. -4 minus 3, they give me -7. And the order pair here, they will be like -2, comma, -7. Now for the second point, -1.
Negative
Who will
5.
do -5. So the same idea, I plug the -1 inside the equation, so I get 2 times -1 minus 3. So here I get -2 minus 3 is -5. The order pair is -1 comma -5. The 0, plug the 0 here. What's the answer? 0 minus 3 is -3. So the point is 0 and -3. The 1, same idea, plug the 1. 2 times 1 minus 3. 2 times 1 is 2, minus 3 is -1. Yes. So 1 and -1. The 2, for the 2 is 4 minus 3. 4 minus 3 is 1. So 2 comma 1. And for the 3 is 3, like Natasha said. So y equal 2 times 3. 3 times 2, 6. 6 minus 3 is 3. So again, 3 comma 3. Now you plotting this point, the order pair. You see the order pair? All this point you're plotting in the Cartesian plane. So I'm going to start from the 0. I have 0 and -3. So this is my 0 for the x, and -3 is 1, 2, and 3. So the first point will be here, around here. Second point is 1 and -1. This is my 1, and the -1 here will be like around this point. Second point, the third point is 2 and 1. So this is my 2, and 1 would be like around here. So to be like around here. This is 2. This is 1. This 1, -1, -2, and -3. -1 again. Gabrieli. -3, -2, and -1. The third point is 3 and 3, so I have 3 here, and 1, 2, 3, like around here. This is the third point, and the same things for the -1 and -5. I have -1 here, -5 around this 3, 4 around here. Then you have to draw a smooth curve between these lines. So the curve would be like around something like this. Here's the curve that passing these points. Okay, so this is the graph of this question. Here is the graph of this question. Any question for this example? This axis and y-axis. It's 1, 2, 3. Makes sense? First of all, you take any random point x, you plug it inside the y, then you get the Cartesian pair of you will get the pair of order pairs, and then you put this order pairs, you plot it in the xy coordinate. Okay, another example is here, example 2. Graph y equal x square minus 2. X square minus 2. So again, the same idea exactly. We're going to draw a table. Here is the table. So I need x and I need y, and also I need the order pairs. So I need around 7 points. So here's 1, 2, 3, 4, 5, 6, and the last one 7. And also I will graph the Cartesian plane. Here is the graph of the Cartesian plane. This is the x-axis, and this is my y-axis. So I will take a random points. The first point is, here is x, and this is my y equal x squared minus 2, and this is the x comma y. I will take a random points. This random I will start from 0. Then I will take positive numbers like 1, 2, 3, and take negative numbers, -1, -2, -3. Now, starting from the 0, what is the value of y when you plug the 0? So y equal what? Matthew said that I will get -2. So let's plug in the 0. So I get here 0 squared minus 2. So 0 squared minus 2, I will get -2. This is correct. So the value here is 0 and -2. What about the 1? 1 squared minus 2. Get 1 squared minus 2. What is it? Is 1 minus 2. Is -1. This is correct. So at 1, I get -1. What about 2? 2 squared is 4. 4 minus 2 is 2. At 2 is 2. So the point is 2, 2. What about 3? I'm going to plug the 3 inside this one. What is the value when I plug the 3? Is 7. This is correct. So here, so I will get here 7. because 3 squared is 9, 9 minus 2 is 7. So the point is 3, 7. Now for the minus 1, the same thing. I have to plug the minus 1 inside this one. So I get y equal minus 1 squared minus 2 is the same, like 1 minus 2 is minus 1. So the point is minus 1 comma minus 1. For the minus 2, the same thing. I have to plug inside here. I will get 2. And for minus 3, I get 9 minus 2, I get 7 again. So the point here is minus 3 comma 7. And the point here is minus 2 comma 2. Now I will plotting this point inside the Cartesian plane. First point is 0 and minus 2. So this is 0. And here is the minus 2. This is the first point, 0 and minus 2. The second point is 1 and minus 1. So this is 1. And this is minus 1. Third point is 2 and 2. So this is 2 and 1, 2. So minus, this is the 2 with the other 2 here. The point will be like around here. At 2 is 2. So be here. At 3 is 7. So this is the point here is 3. Here is the 3. And the 7 is in the top up. So 2, 3, 4, 5, 6, and 7. So the point will be like around here, the 7. And here is 2. I mean 3. So the point will be around here. Same thing on the other side, minus 1 and minus 1. So the point would be like around something here. Minus 2 and 2. So this is 2, minus 2, and this is 1, 2 here. And the minus 3 and 7. Here's the minus 3 and 7. Minus 3 is the minus 3 and 7. So the point will be around here. This is minus 3. Again, this is minus 1, minus 2, and minus 3. Yes, go ahead, Richard. Minus 1 here, minus 2.
Wouldn't it just be easier to find the x-intercept, the y-intercept, and then the slope, and then graph it instead of finding each individual point?
Yeah, this is correct, but the question asks plotting by using the table. You graph this question by using the table and plotting the point. So I have to do these steps, that's why.
Oh,
This is
okay.
correct, I can do the same like you said, but the question not asking about this way, they ask about this way. I have to put a point, and this point I have to represent it in a Cartesian plane. Then I have to graph a smooth line between these 2 points. That's why I have to do the steps. So the same thing here, I have to graph the smooth line that connect between these points. So the graph will be like around something like this. And here, like this. And the same things for the other side here. Do we have always to graph the 7 points? No, you can graph like around 5 points or 4 points. It's not you have to graph like 5 or 7 points. No, sometimes you can graph like 4 points or 5 points. You're not sure to graph all the points. I mean, or it depends on the question sometime. If the question asks you to graph like 7 points, you have to do the 7 points. But if the question asks about to graph just some points, you should to do only the some points. So it depends on the question, actually. Any question for this example? Here's the x-axis, and this is the y-axis. Is this is gonna be in the exam or the next one? This will not be in the exam. Yes, this will be in the next exam, second exam, not in the first exam. This will not be in the first exam. Okay, now after we graph the y equal x squared minus 2, we have another example. The last one is graph example 3 is graph y equal the absolute value of x. So last time I talked about, like in the previous class, I talked about the absolute value. I said the absolute value, they change all the negative to the positive, and we keep the positive the same answer. So here the question the example asks to graph this absolute value. So the same things, we have to use the random points. Then this random points we have to plot it in the Cartesian plane. So we're going to use like around 5 points. 1, 2, 3. 1, 2, 3. 5. So I have 5 around the points. And the same things we have to graph the Cartesian plane. So the Cartesian plane, something like this. So the points here are, so here I have x, here I have y equal the absolute value for x, here I have the x comma y. So the point is here -2, -1, and 0, and 1, and 2. Now, what's the absolute value for 0 when I plug the 0? What's the absolute value for 0? When I plug the 0, yes, 0. So the absolute value for 0 is the same thing is 0. The absolute value for 0, they give me 0. So the first point is 0, 0. Now, what's the second point? Is 1. What's the absolute value for 1? What's the absolute value for 1?
1.
Is 1, exactly. So when I plug the 1, it's positive already, so they keep it 1. So they get here 1. So the order pair here is 1, 1. What's the absolute value for -1? When I plug the -1 inside the absolute value, what I get? Aziza said 1. This is correct. Because like I said before, the absolute value, they change the negative to the positive, and the positive keep it positive. So here I get -1, 1. What's the absolute value for 2? -2. What's the absolute value for -2?
2.
Is 2, correct. So here the point is -2, 2. What's the absolute value for 2? Positive? Is 2. Yes, correct. So 2, 2. Now I'm going to plotting this point in the Cartesian plane. So the first point is 0, 0. So this is the point 0, 0. Second point is 1 and 1. So again, this is 1, 2, 3, 1, 2, 3. And here I have 1, 2, 3, 4. First point is 0, 0. Second point is 1 and 1. So this is 1 here, and this is 1. So the point would be like around something like this here, around here. So the point, this is 1, and this is 1. So the point will be around here. The third point is 2 and 2. So at 2, this is 2, and the y value, the y coordinate is 2. So here's the 2. At 2 is 2. Now at -1 is 1. At -1 is 1. So again, this is my -1. At -1 is 1, and also this is 1. -1 and 1. And the third one is -2 and 2. So this is -2, and this is 2. So actually, when I graph this one, the absolute value, it's look like something like this. Like this. Something like this. Make sense? Any question? Any question for the absolute value? So this is the graph of the absolute value question. Anyone has a question for this example? Clear? Okay, so we finished the graph for like most the important examples. So first of all, I start for example y equal 2x plus minus 3, the linear line. This is a linear equation. I get linear line. Then I move to the next example is the quadratic equation, x squared minus 2, the graph looking like a parabola. And then I move to the example, the y equal the absolute value for x. It's look like a linear line or a line, but this line is not goes under the x-axis. Everything is positive. The value most of the time is positive, and all the answer is above the x-axis. Any question for this example? Okay, so now let's go to the important things in this section is the intercept. So here the intercept. Intercept. So I have two kind of intercept, the x-intercept and the y-intercept. So I have x-intercept intercept. I have the x-intercept, and also at the same time I have the y. Here the y. Here is the y-intercept. So the x-intercept, I have to know what is the meaning of x-intercept. What is the meaning of x-intercept? Any idea, like from before, about the x-intercept? What is the meaning of x-intercept? Any idea about in high school or any, if you take another math courses? Where the line across the x-axis. This is correct, Matthew. This is correct. What also do you know about the x-intercept? Any point across the x-axis. This is correct. What else? How can I find the x-intercept? A point that made when a line intersect the x-axis. Also, this is correct. Points that is made when a line intersect the x-axis. This is correct. How can I find it? Yes, by setting y equals 0. Matthew said how we can find it. This is correct. When I set y equals 0, then I have to solve it for x, so I can find the x-intercept. So let me write down here the definition of the x-intercept, or how we can, what is the meaning of that? The x-coordinate of points where the graph of the equation, intersect the x-axis. X coordinate of the points. What is the meaning of x coordinate? So suppose in the beginning here, the order pair for any, like the order for order pair is parentheses x comma y. So this is the order pair. It's x comma y. So the x is called the x-intercept, and the y called the x is the x. I mean, like the x-intercept equation. I mean the x-coordinate. And the y called, this y up called is the y coordinate. This is just a definition. What's the meaning of x and y? The x is the x coordinate, and the y is mean the y coordinate. Now, the x coordinate of a point, I mean like the x of the order pair, if you go up, here, the x coordinate means the x of the order pair of points where the graph of the equation intersect the x-axis. Now, to find this point, I have to do one thing only. I have to set, so the question here, how we can find it? To find the points by setting y equals 0. Then we solve for y, for x. This is the idea how we can find it. To find this point, we have to set y equals 0, then we solve for x. Now, for the y-intercept, the graph, let me graph a small picture to show you where is exactly the y, the x-intercept. Suppose I have a graph like this, and the function look like this here. So if I have the graph like this, so this point here and this point and this point are called the x-intercept. This point here and this point and this point, the x-intercept. Now the y-intercept, the same idea like before, same like x-intercept, but the definition is changed, is the y-coordinate. Instead of the x-coordinate will be the y-coordinate. So the same, the x-coordinate here, instead of that will be the y-coordinate. The y-coordinate of points where the graph of the equation intersect the y-axis. Now the question is how to find this point. To find this point, just set what I have to do to find this point, the y-intercept. Any idea? Yes, Matthew. Yes, exactly. Just set x equals 0 to find the y-intercept. So the question is to find, now the important thing is to find the point by setting x equals 0. Then we solve for y. And the graph, to know how is the look like, how is the y-intercept look like. So if I would like to graph a symbol, this is my Cartesian plane, and this is my x-axis, and this is my y-axis. Suppose I have the graph like this. So the point where the function intersect, here's the graph. So the point where the function intersect the y-axis, I mean here, this point is called the y-intercept. This is the y-intercept. This is my y-intercept, the blue point in the y-axis. Okay, so this is just like general idea how to find just the definition of the x-intercept, and also how to find the x-intercept. Also the same things for the y-intercept, the definition and how to find it. Now next time we're going to solve this example. Just I want to write it down. Find, or just give me like the hint how we can find the x and the y intercept of the function. If I have function like this, of the function is x squared, I mean y equal y y equal x squared minus 2. So again, to find the x-intercept, like I said before, just set x equal. How I can find that? Find x. How I can find the x-intercept? How can I find the x-intercept? By setting y, by making y equal 0. And how can I find the y-intercept? X equals 0. This is correct, Matthew. Next time, we're going to solve this question, this example, and I will show you step by step how we can find the x and the y-intercept. Could you tell us what topics are going to be on the exam? So I have a question here. Can you go back, please? Yes, I will go back. So next time we will solve it. What is the topic of the exam? Again, if you need anything, here's the previous slide, Aziza. Will there be a review for exam 1? We'll talk about this later. So right now it's 2 o'clock. Have a good day, everyone. I'll see you next week.
What the heck is this?